For most of human history, our solar system felt like a closed box. Everything we saw belonged to us. Planets, asteroids, comets, all were our neighbors, born from the same cosmic cloud. Then, in 2017, everything changed. We had our first confirmed visitor from interstellar space. It was named Oumuamua, and it was weird. Very weird. It was shaped like a cigar or a pancake, and it was accelerating away from the sun without any visible tail. Comets accelerate because ice turns to gas, acting like tiny rocket thrusters. But Oumuamua had no gas, no dust, no coma. This non-gravitational acceleration, without any visible outgassing, was the core of the mystery. Natural explanations were proposed, like it being a hydrogen iceberg, but these theories had their own problems. This led some serious scientists to ask a wild question. Could it be an alien artifact? A piece of technology, like a solar sail? We'll never know for sure. It's gone forever, leaving us with a tantalizing mystery. Scientists wished for another chance. A chance to study an interstellar visitor up close. And then, we got one. In late 2019, a robotic sky survey called ATLAS Asteroid Terrestrial Impact Last Alert System spotted a faint, moving object. Software automatically flagged its path. It wasn't in a neat orbit, it was just passing through. It was named Psi 2009 Y4 ATLAS, and it was our third confirmed interstellar visitor. And unlike Oumuamua, this one looked normal. It had a coma, a tail. It was a classic comet. Finally, a chance to study a normal piece of another solar system. What was it made of? How was it different from our comets? The scientific community was buzzing. As it got closer to the sun, it brightened dramatically, promising to be a spectacular sight. Telescopes around the world were pointed, ready to analyze its light. But then, something strange happened. It got too bright, too quickly. Its activity was increasing at an unusual rate. Something was happening to our interstellar visitor. Then, in April 2020, telescopes watched in shock as ATLAS fell apart. It didn't just fizzle out, it disintegrated. The single nucleus broke into several large pieces. The process happened in stages. One major fragmentation, followed by another a few days later. The Hubble Space Telescope confirmed it. Our pristine interstellar comet was now a cloud of icy debris. The chance to study it was gone. But a new, fascinating mystery had just begun. Why did it break up? Comets are fragile, but this disintegration was dramatic. Our first interstellar visitor was an unexplained accelerator. Our second was an unexplained disintegrator. This strange behavior inevitably leads us to the same wild question we asked about Oumuamua. Let's do a little what-if exercise. What if 3I Atlas wasn't a comet at all? What if it was an extraterrestrial probe sent to study our solar system? Perhaps it was a reconnaissance mission. Its approach to the sun was part of its plan, a gravitational slingshot to propel it to its next target system. But it miscalculated. The sun's heat or gravitational forces were too strong, causing a catastrophic malfunction. The disintegration wasn't a natural comet breaking up. It was a highly advanced piece of technology failing under stress. Or, let's take a different route. What if the breakup was intentional? A self-destruct mechanism designed to prevent its technology from falling into the hands of a primitive species, like us. The comet was just a shell, and its disintegration was the ultimate leave-no-trace policy. A third option, it wasn't a failure but a deployment. A mothership arriving and releasing smaller probes to study the system. What we saw as destruction was actually the successful start of its mission. It's fun to speculate, isn't it? These stories are exciting, but a good scientist must follow the evidence. And the evidence for 3I Atlas points to a conclusion that is less science fiction, but no less fascinating. So, what really happened to our interstellar visitor? The story likely begins hundreds of millions of years ago in another solar system. A gravitational nudge sent a small comet on a long, lonely journey between the stars. Recent research, led by astronomer Quan Ziye, concluded that Atlas was likely not a whole comet, but a fragment of a larger one. It probably broke off from its parent body long ago, perhaps during a close pass to its own star, and was ejected into interstellar space. This is crucial. It means Atlas wasn't a solid, cohesive body. It was likely a rubble pile comet. Imagine a collection of rocks, dust, and ice, all held together loosely by their own feeble gravity. We've seen this before in our own solar system, with comets like Shoemaker-Levy 9, which was torn apart by Jupiter's gravity. As this fragile object approached our sun, the heat began to sublimate its ices, turning them directly into gas. These jets of gas weren't uniform. They acted like uneven rocket engines, spinning the loose collection of debris faster and faster. Eventually, the centrifugal force from the spinning simply became stronger than the weak gravity holding it together, and pop. It flew apart, no alien self-destruct needed. This spin-up theory perfectly explains the observations, the initial rapid brightening, and the final catastrophic breakup. So 3I Atlas wasn't an alien probe. It was something almost as exciting, a primordial piece of another solar system, a pristine sample preserved in the deep freeze of interstellar space, telling us how planets form around other stars. So how does the fate of Atlas change our understanding of Oumuamua? For one, Atlas had a coma. We saw the gas that was causing its activity. It behaved like a comet even if it was a fragile one. Oumuamua did not. Its acceleration remains the central mystery. No dust, no gas was detected. This strengthens some natural explanations for Oumuamua, like the nitrogen icebergs theory. Nitrogen gas would be invisible to our telescopes. The hydrogen iceberg theory, on the other hand, is weakened, as such an object would likely be even more fragile than Atlas. Other theories, like it being an extremely porous dust bunny, are still on the table. The fact that Atlas had a natural explanation doesn't disprove the alien theory for Oumuamua, it just makes it a very, very high bar to clear. Atlas also showed us that interstellar objects can be extremely fragile, much more so than the comets in our own solar system. This might be because they've been traveling for millions of years, slowly being worn down by cosmic rays and tiny impacts. So, the mystery of 3I Atlas has a solid scientific explanation. The mystery of Oumuamua, however, remains. Each new visitor, whether it behaves as expected or shatters into pieces, teaches us something new about the incredible diversity of the cosmos. So what's the big takeaway from all this? It's that the galaxy is a connected ecosystem. Pieces of other solar systems are constantly drifting through our backyard. These interstellar travelers could even be responsible for seeding planets with the chemical building blocks of life, a theory called panspermia, and soon we'll be finding many more. Observatories like the upcoming Vera C. Rubin Observatory will scan the entire sky every few nights. It's expected to find dozens, maybe hundreds, of new interstellar objects every year. We'll finally have a large enough sample size to understand what's normal, what's rare, and what's truly weird. The story of 3I Atlas is a perfect example of the scientific method in action. A strange observation, followed by wild speculation, which is then tested against evidence, leading to a new, more refined understanding. It's not as romantic as a self-destructing alien probe, but the real story is, in many ways, even cooler. It's a reminder that there are real, natural wonders in our universe that are just as mind-bending as any science fiction. But the debate about Oumuamua is still open. What's your favorite theory? Let us know in the comments. If you want to stay updated on the next interstellar visitor, subscribe to Cabby Brain and hit the bell. Thanks for watching. If you're enjoying this cosmic detective story, take a quick second to subscribe. It helps us make more videos exploring these awesome mysteries. It's also worth noting the difference in scale. Oumuamua was small, maybe the size of a city block. Atlas, before it disintegrated, had a nucleus several kilometers across. It was a much more substantial object. Astronomers are now combing through old data and have found hints of other interstellar visitors that were missed at the time. Let's not forget the second one we found, 2I Borisov. It was a perfectly normal-looking comet, behaving exactly as expected. So, our tiny sample of 3 visitors gives us 2 weirdos and 1 normal guy. That's a strange ratio. This might suggest that the population of interstellar objects is far more diverse and strange than the objects in our own solar system. Each one is a clue about the conditions in its home system. Even though Atlas broke up, scientists could still analyze the gas in its coma. The findings showed it was chemically similar to our own long-period comets, confirming it was indeed a dirty snowballs like ours. This is a profound discovery. It suggests that the processes that build solar systems might be quite universal. So, while the alien probe idea is exciting, every piece of actual evidence we gathered for Atlas points to a natural origin. And in science, we must stick to the evidence. The burden of proof is on the extraordinary claim. The lack of a perfect natural explanation for something isn't, by itself, evidence for an artificial one. It simply means we have more to learn. And that's the best part of science. The universe is under no obligation to make sense to us, or to conform to our expectations. Our job is to keep watching, keep questioning, and be ready for whatever comes next. In just a few years, our entire perception of the solar system has changed. We've gone from thinking we were alone in our cosmic neighborhood, to realizing we have visitors all the time. Another interesting detail about Atlas is its orbit. It's closely aligned with the ecliptic plane, where the planets orbit. This is unusual. We'd expect visitors from other stars to arrive from completely random inclinations. Is it just a coincidence? With a sample size of 3, it's impossible to say, but it's another piece of data for the mystery file. This is why projects like the Comet Interceptor are so important. It's a mission designed to sit and wait, and then launch at a moment's notice to fly by the next interstellar object we find, getting data we can only dream of now. Imagine what we could learn then. Perhaps then we could finally close the case on Oumuamua. The era of interstellar archaeology has just begun. We are now finding the messages in a bottle from other star systems. Each one, whether it's a simple rock or something more, has a story to tell, and it's our job to learn how to read them. Stay skeptical, stay curious, and we'll see you in the next video. This was a Cappy Brain production. So, 3 visitors, 3 very different stories. It shows how little we know and how much there is still to learn. The lack of outgassing from Oumuamua remains its most stubbornly strange feature. Atlas, on the other hand, was an overachiever in the outgassing department before it fell apart. This difference strongly suggests they are fundamentally different types of objects, likely formed in very different environments. Our comets are rich in water ice. But what if other solar systems have different frost lines? A system around a hotter star, or one with a different chemical makeup, might produce comets of frozen nitrogen, or even solid hydrogen. These exotic ices would sublimate differently and could explain Oumuamua's invisible push. That's why the next visitor is so important. We're ready now. We know what to look for. The lessons from Oumuamua and Atlas have prepared the entire astronomical community for a rapid response. The age of interstellar object science is just beginning. What do you think is the strangest thing we've found in space so far? Let us know in the comments. If you want to join us on our journey to the next cosmic mystery, be sure to subscribe. Speculation is fun, but evidence is king, and we'll be here to analyze the evidence from the next visitor, whatever it may be. The universe is sending us clues. We just have to be ready to